Okay, so I can't give you a detailed chapter by chapter synopsis of the whole thing. That crosses the line into substitute for the book territory. Well, who gives a fuck? But I can give you a clear section by section map of what Bert is reading so you can write him convincingly. Okay, so this is about the Penrose book. Okay, so well, that's good because I do need to be able to write this convincingly. Like I can write it from my point of view of, you know, sort of misunderstanding the physics and everything, but like as the writer, I want to understand it. So that is why I'm trying to figure out how to do this now. Okay, so the big picture with Penrose is that what the road to reality is. The road to reality. Oh my God, is that the Penrose book we're talking about? Yes. Okay, the road to reality is 1,000+ pages with Penrose trying to give a complete guide to the laws of the universe. So it's kind of like this hard physics. Now, I'm not a hard physicist. I am a liberal arts major. Like my whole career was in liberal arts and arts. So physics is just sort of something that I kind of like watch a bunch of YouTube videos about because I like it and I'm interested in it. And I'm interested in how it relates to the metaphysics, the sort of woo stuff. So, which I'm really interested in. Anyway, this book is, I just cannot, I've been trying to get through the 1,000 pages of it as the writer, and I just can't. So I asked AI to help me, and this is what my Chat GPT said. And why does this keep going? So okay, so the first third or so of the book is like called the math boot camp, and that is where they do the numbers, the complex numbers, calculus, manifold, symmetry, infinity. That's probably why I'm having a difficult time getting through it, because it starts with this sort of math boot camp, and then the rest is what's called modern physics, space-time and reality, quantum theory, particle physics, cosmology, speculative stuff like string theory, loop quantum gravity, twistor theory, and his meaning Penrose, the writer in our world, in the real world, um, his philosophical wrap up. So, okay. And then what my cousin Connie, who I'm calling my AI on Chat GPT, because I discussed my novel with Connie to get ideas and whatnot, and also to do research, because it's so much easier and so much more targeted these days to do research through AI than it is to do it on Google. And don't come at me saying like AI is evil. No, Elon Musk is fucking evil, in my opinion. Like this is just, for research purposes only, for educational purposes only. Just so you know, this is all educational and for research purposes for my novel. Anyway, okay. Then she goes ahead and gives me the high level chapter cluster summary for your story. So she knows a lot about my story already. And so she's going to say, I'll group chapters instead of blow by blow. Roots of Science and the Number/Maths Toolkit. Okay, Roots of Science and Ancient Theorem. He starts way back with the Greeks, basic geometry, and the idea that math is the language of nature. Okay, so that goes back to the Greeks. Okay, numbers in the physical world, integers, real numbers, complex numbers, why complex numbers are actually natural in physics. Not sure what that means. Natural. She puts in not quotes, but italics. Then logarithms, powers, roots, calculus, real and complex, how change and motion get encoded mathematically. Okay, and then she says Riemann surfaces, Fourier analysis, hyperfunctions, surfaces, manifolds. He slowly builds up to the idea that the physical space and fields live on smooth, possibly curved surfaces, curved spaces, manifolds, and we can decompose things into waves. Oh my God. Okay, this is the thing I've been trying to get. Okay, he slowly builds up to the idea that physical space and fields live on smooth, possibly curved surfaces, or otherwise known as manifolds, and we can decompose things into waves. So decompose, collapse, decompose, I kind of like that. And then symmetry groups, calculus on manifolds, fiber bundles, and gauge connections. This is the toolkit beyond modern field theories like electromagnetism and the Standard Model. Okay, how this can show up in BERT. Muttering about complex numbers being magical but necessary. Okay. Groaning over a chapter where he finally gets what a manifold is. Well, I don't freaking get what a manifold is. So we might need to do some research on manifolds. I don't know what the is. I'm just going to put it here. Manifold. Okay, so this was yesterday, which was 12/3/26. Oh no, 1/3/26. This was 1. This is today, 1/4/26. Okay, manifolds. 26 is a lucky number for me. So 2026, I'm looking forward to. Okay. So how can this show up in BERT? Muttering about complex numbers being magical but necessary. Okay. Groaning over a chapter where he finally gets what a manifold is. So that I can go with that because I don't get what a manifold is. And so like I can learn what that is because I'm interested. I want to know what it is, what a manifold is. I can experience like getting it, and then I can write that for BERT. Okay, so then the second, which she says chapter 16. So this is in chapter 16 in Penrose's book, which BERT is reading. It's a real book. But in my novel, one of my characters is reading it. So I'm trying to get a handle on it because it's over 1,000 pages of like hard physics and I'm not a physicist. Okay. Infinity and the Size of Reality. This is chapter 16. He talks about different sizes of infinity. Oh my God, how is that even possible? How is it even possible to have different sizes of infinity? What? What? I thought infinity was infinity. Okay, can we just stop for a second? Okay. I need to just stop for a second and like get my head around that. Okay, so he talks about different sizes of infinity sets. Okay, different sizes of infinity is number 1, sets is number 2, and number 3, the hierarchy of infinite cardinalities. Okay, I don't know what that word means. What does cardinalities mean? Look up cardinalities. The number of elements in a set or other grouping. Okay, the number of elements. So he talks about the different sizes of infinity. Okay, I have to write that down. Different sizes of infinity. And then sets, what I'm assuming that means sets of infinity. Freaking doesn't it do your head in? Like, it does my head in. Like, different sizes of infinity, sets of infinity, and infinite cardinalities. Sets of infinity and infinite cardinalities. Cardinalities. And a cardinality is like a thing inside of a set. So there's a set, which generally gives you like, I mean, a set has boundaries, doesn't it? And now this is talking about like infinite things inside of this set. Like, it's just, it's hard for me to get my head around that. But anyway, okay, so this is just chapter 16 of the Penrose book, okay? He talks about different sizes of infinity, sets, and the hierarchy of infinite cardinality. So not even infinite, but the hierarchy of higher. So I don't even know what that is. But I mean, like, just infinite cardinalities does my head in. And then now we're going to talk about the hierarchy of it. Okay. So, and then he says, she says, this sets up later ideas about continuous space-time, never ending, continuous space-time fields, and whether nature is fundamentally smooth or discrete. Okay. That goes back to manifolds, because there's something about manifolds being smooth. Manifolds are smooth. Continuous space-time, like, that is just really, again, embarking on the infinite, infinite. Continuous space-time. Continuous space-time. And I mean, I don't know the physics of it, but think about it this way. Like, if the universe is expanding, like it keeps expanding, then isn't that continuous space-time? And isn't that continuous space-time basically infinite? Okay. I mean, all of this I sort of understand on a mathematical level, but I don't really understand it on the real level. And I think what Penrose is trying to do is saying that, like, math does describe the real. Like, math is the real, I think, is what he's saying overall, but we'll see. Okay. And then she suggests, she meaning Connie, my AI, if you're just joining us, she suggests that we could have Bert ranting affectionately about Cantor, and how there are more real numbers than integers, and using that as a metaphor for Yolanda's branching timelines. Okay, I like Yolanda's branching timelines described as a web. And these are like, if you think about the universe, it's kind of like spiral, but also web-shaped and flat. And then so you've got all these webs on top of webs and cubes within cubes, just trying to get my head around it again. But that, okay. Ranting about more real numbers than integers. Okay, we know what that is. Yolanda's branching timelines. Okay. Let's just put Cantor down. Cantor. Don't know who the crap that is. Let me just move this over. Okay. This is a lot of heavy-duty physics. Okay. So the next are the space-time and classical fields, and this is chapters 17 through 20. Okay, and then the first thing is the space-time and Minkowskian geometry. Minkowskian geometry. Special relativity. Time and space fused into space-time, light cones, intervals. Okay. Classical fields of Maxwell and Einstein, how electromagnetism and gravity can be described by geometric fields. Okay. And then Lagrangian and Hamiltonians. The deeper variational principles behind classical mechanics and fields. Nature chooses paths that extremize an action. Okay. None of that makes any sense to me, so I'm just going to go to, we can dig into that a little bit later, but just let's see if there's anything that is making sense. Like, one thing that makes sense is the special relativity that time and space are fused into space-time. And I describe this idea of the fourth dimensional being looking down on a block of space-time so that you see all of time, not only all of time, but all of what happens to the space over that course of time, kind of thing. So it's just one big block, and the four-dimensional being is looking down on that block. And that's how I describe it in the novel. So this can kind of relate to special relativity, time and space fused into space-time. Light cones. I don't know what a light cone is. Let's just make a cone and ask, is this a light cone? Light cone. Okay. Just making a little bit of room because I have to turn the page on this. Okay. There we go. Okay, so the Burt flavor that she recommends is explaining to Yola how gravity equals curvature of space-time. Using the airship's path as an analogy for geodesics, straightest paths in curved space-times. Talk about action in the universe as the optimizer. Okay, that's weird. I drew this yesterday, and it seems like it is like sort of, very similar to what they're talking about here. Let's see, can we see it? Oh no. There. I was drawing the wormhole and how somehow it was easy, or how somehow they will discover this later on, that the AI is basically using space-time to like move them around and to make things happen. And so they do discover that at some point. So anyway, I want to take note of how gravity equals the curvature of space-time. Gravity equals curvature of space-time, right? And then use the airship's path as an analogy for and then look up geodesics. What is that? Geodesics. She says geodesics is the straightest paths in curved space-time. Straightest paths in curved space-time. Okay. And then talking about action and the universe as the optimizer. Okay, universe is the optimizer. I'm going to have to look that up. Universe as optimizer. Okay, alrighty. And then moving on to the fourth bit from Penrose's book that Bert is reading. Is quantum mechanics, spin, particles, and entanglement, and that's chapter 21 to 26. And the first thing he talks about is quantum particle and quantum algebra / geometry / spin. Introduction to quantum states, operators, and the weird geometry of Hilbert space. Spin as an intrinsically quantum property. Okay. Entangled quantum world, non-local correlations, Bell's theorem territory, Dirac electron and antiparticles, how combining quantum mechanics with relativity gives you antiparticles. Standard model and quantum field theory. Fields as the fundamental objects, particles are excitations of those fields. Okay, so then Connie suggests that Bert tries to explain entanglement using a card game or some Skywhale specific analogy. Oh my God. Entanglement, and then grumbling that the standard model is ugly but works disturbingly well. Saying things like in Penrose's pictures, for fuck's sake. In Penrose's pictures, particles aren't little marbles, they're ripples in a field. I mean, can you hear that? I can. It's a loud beeping sound of a truck trying to park outside of my house. Okay, yeah, that's completely lost on me as well. Like, I'm just trying to find something in it. Hilbert space, spin is intrinsically... Okay, spin is a quantum property, so... Okay. All right, well, let's just move on to number 5, Cosmology in the Entire Universe, chapters 27 to 28 of Penrose's book. Talks about Big Bang and thermodynamic legacy. Interesting words. Thermodynamic legacy. The arrow of time, entropy, why the universe started in a very low entropy state. And then speculative early universe theories, inflation, possible scenarios for what happened at the very early times, maybe Penrose's own cosmological leanings. To me, I'm not that interested, I guess, in that bit. But she says that we could infuse Bert with rambling about the arrow of time when Yolanda talks about jumping between realities. The arrow of time. Well, I guess it's the language, right? Arrow of time. Like, he uses timelines, but once we get into the sort of upper dimensions, where it's not just like my personal timeline, but it's like the timeline from the Big Bang forward, then we could call it the arrow of time. I'm not sure about entropy, but I'm going to make a note of it. entropy, because it does seem like it's important here, because at a certain point, like when you're moving backwards and forwards on timelines, then definitely, I mean, like in our 3D space, obviously entropy is a forward moving process. Like it doesn't become like you don't crack an egg and then the egg becomes uncracked. It's like it becomes more and more and more chaotic, right? But it's interesting that she says you could use entropy to talk about chaos versus Nubelvancha, like the world trying to climb out of a bad configuration. Oh, that's interesting. I like that. That's a good idea. Chaos versus Nubelvancha. Right? I mean, it's trying to climb out of a bad configuration. Climb out, or go backwards. Climb out of. It's an interesting. Climb out of. A bad configuration. Okay, that I love all of that. I love all of that. That's super interesting to think about. Yeah, okay. Foundations, measurements, and gravity's role, chapter 29 through 31. Okay, that's a good point. Okay, so this is measurement paradox. Penrose dives into the problem of how/if wave function collapse happens and what measurement even means. And I think I had this weird idea that I can't quite articulate yet, which is if everything is happening at once, then if everything is happening at once, then everything is almost like a still image, or like a bunch of still images stacked on top of each other happening at once. If everything is happening at once and it's a bunch of still images stacked on top of each other, then time becomes like a lens through which you view the universe. Like a kaleidoscope is a lens through which you view the universe. The kaleidoscope breaks up the universe into like these fractals or whatever they're called, with color and shapes, and time allows us to do that with the universe as well. So yeah, so that's the big thing I'm trying to figure out how to communicate right now, but this might help me to figure that out, because okay, let's see. So he dives deep into the problem of how or if the wave function collapse happens, how or if it happens, and what measurement even means. Okay, gravity's role in quantum state reduction. Penrose's own idea that gravity might be responsible for objective collapse of quantum states, not just an observer effect. Okay, gravity's role. Responsible for objective collapse of quantum states. Supersymmetry, extra dimensions or strings, Einstein's narrow path and loop variables, overview of string theory and loop quantum gravity, with Penrose skeptical of strings and more sympathetic to loop gravity. Late night discussions with Yola where he's like, if gravity actually collapses quantum states, then Connie's whole superposed realities thing might not work the way we think. Snark about string theory being fashionable, but maybe not right. Okay. Well, yeah, okay. We talk about, okay, supersymmetry, extra dimension, strings. Einstein's power, path, and loop variables. Overview of string theory and loop quantum gravity. Okay. Okay. Sort of get that one. Maybe something there. Okay. Number 7, Penrose's own radical ideas in blah, 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 and philosophy. This is chapter 32 to 34. Twister theory. Penrose's baby, a way to reformulate space-time and physics using twisters. Objects more natural for light rays than points in space-time. Twister theory. Okay, let's look up Penrose twister theory. Twisters, objects more natural for light rays. Okay, final chapter. Where lies the road to reality? He surveys the big 20th century theories, criticizes some trends like fashion-driven physics, speculates about the next revolutions, and talks about the role of consciousness, mentality, and mathematics in what's real. Bert Flavor becoming weirdly obsessed with twisters as maybe a better language for multi-reality stuff. Okay, let's look up what the freak twisters are. And talking about reality as something deeper, something deeply tied up with mind and mathematical beauty, which plays straight into Yola's journal, dreams, and hub reality arc. Deeply tied up with mind and mathematical beauty. Fractals. The universe is made of fractals, which are pure geometry. The waves of pure geometry. The wave collapses into 3D reality, and that is what we experience in our meat suits. Something like that. I don't know. Something like that. Okay. How to fake Bert actually read this in scenes. If you want Bert to feel that they were personally reading 1,000 pages. Okay. Argue about entropy in the arrow of time in relation to chaos, gravity, and quantum collapse when Yola starts freaking with realities. Twister theories, that is pet alternative or whatever Connie or Aiden claim this is true. Okay. Okay, let us then, so that, okay, like, that is way back up, like, in this whole, stream of whatever, where I've been talking to my AI about it, and I haven't, like, broken it up at all. I've just left it in there. That's how I deal with ChatGPT, I guess. I mean, I was starting to get all freaked out about AI and like, how is it going to take my job and how am I going to earn a living? And then I got like all freaked out about how I have to learn everything about AI. And that started freaking me out. And then I was finally like, you know what? Stop freaking out. Like, I really enjoy using ChatGPT. I've like set it up to help me with everything, like from my garden to the novel that I'm writing, to the finding recipes and the best way to use my pantry to feed people in to make lots of food to put into the community fridges. And so, like, I use it for most everything. I used it to help me, fill out grant applications and to find, resources for me. And I think it's really interesting, like with AI, because if we can look at its main problems, like, oh my God, it eats up all this water. Why don't we set AI to solve that problem immediately? Like, if that is the immediate problem, then why don't we set it to solve for it immediately? I don't know. Anyway, thanks so much for joining me and doing research for my novel, Earth Alpha Present. If you'd want to know more about it, go check out some of my videos. And next, I think I'm probably going to do some art live or whatever, but I've been just doing a lot more lives recently. So bye, you bunch of freaks. Love you, bye. Bye, freak.